is equal to 3 times 128.4. Look for that on IB tests. They'll say, how much is left after this much time, right? Oftentimes the number they give you is an even number of half-lives, right? Okay, so if it's 3 half-lives, well, after 1 half-life, how much is left? 16 after the next half-life, 8 after the next half-life, 4 after the next 2, after the next 1, after the next a half, etc., etc. It just goes like that. Now, suppose they give you an answer that's not exactly an even number of half-lives. Can you fudge it? Can you kind of look at it and go, okay, it's between 2 and 3 half-lives, so the answer is going to be between, yeah? Can't you do that? Yeah, you can do that, and then on a multiple choice test, it's way faster than like plugging the numbers in like this. You can just go in there and go, okay, can't be that one, can't be that one, can't be this one, right? Chances are you can just figure them out like that, right? Okay. In fact, can't we make a new formula? Should we just make a new formula? The kids last year did this new formula, right? They did n equals n naught. Can't you just do it in terms of half-lives? 2 to the negative, what is it, number of half-lives? Is it just number of half-lives? Right? Number of half-lives is a real number, right? It's the fractional number. You just divide the time by the half-life, right? And then it's just you have your own formula, right? And you can show, it's not exactly really exciting, but you can show that there's a base change operation you can do that just shows that they're the same thing. Yeah?
Replace the number of half-lives with how much time in the decaying?
Yeah, time divided by half-life. Yeah. So this thing is just time divided by, right? Literally. So yeah, whatever you care to do, it's a concept. Okay. After what time is there 23 grams left? So that's our next question, right? I don't think there's any slick answer to this one. Okay, 23 grams left. I think we're going to have to just plug the numbers in, right? So 23, God help you if you're dyslexic, right, is 32 e to the minus lambda t, right? So I'm just going to, let's just put the numbers in there, right? Okay, or the symbols in there. So what are we solving for? I guess we're trying to solve for t, aren't we? Yep. Right, so let's solve this thing over n naught, right? Let's take the natural log of this, right? Okay, and then what are we solving for? Let's put negative lambda like that. Is that what we're trying to do? And that's going to give us t. Right, so it's going to be natural log of how much we have left, which is 23, divided by 32, which could be the same number. Look at those things. Right? Divided by negative this guy. Right? And that'll tell us how much time. Hopefully it'll be a positive number, meaning it happens in the future, right? Natural log of 23 divided by 32 divided by negative 0.005398. What is that? What's that number? I need that number better. I don't have it. I'm rounding here. I'm very sorry about this. You get 61.2 seconds roughly. Yeah? Okay. You didn't round? Are you morally pure? Yeah, this decays pretty quickly. In fact, there's a little lab that you can do where, and this is a really cool thing, there's this natural decay that occurs, and it's a decay from something that's not water soluble to something that is water soluble, right? And the water soluble thing has a very short half-life, and so you can get this thing from like the Department of Energy, and you run water through basically what looks like a filter, right? And it washes out this very short half-life thing. It's like, I think it's sodium something, right? Okay, and that thing has a half-life of like 3 minutes or something. And then the kids can sit there with Geiger counters, and they've got this radioactive stuff in the water. And yeah, that does sound like fun. But you can get this, like with a Geiger counter, you can get these like exponential decay curves. I'm a little scared of the radioactive stuff in the water, though. I don't know. It sort of put me off on that, right? Okay, so then the final question is, what is the activity when there's 23 grams left? Here's the mass. It looks like we need to use that mass, right? And I think the activity isn't the activity going to be this decay probability times the number of atoms we have, right? Okay, so that's going to be, the activity is going to be lambda n, right? So that's going to be 0.005398 per second, right? Okay, and then the number of nuclei that we have is 23 divided by 210.987. Sig figs because we can, right? This is grams per mole, right? And then we need to multiply by avocado's number, right? I'm going to mess you guys up. 23, right? And this is atoms per mole. So our decay probability, right, times 23 divided by 210.987 times, and this thing, by the way, has avocado's number built into it, but I'm not going to use that because I'll get a different answer. I just want you to know. I don't want you to feel bad, though, that your calculator doesn't have that, okay? As naturally you would. Wow, that's a lot of activity. That's a huge number. 3.54 times 10 to the 20th decays per second. Anybody else get that number?
Yeah, I did.
That's tremendous. Then the question is, how could you ever measure that much decay? And the answer is you couldn't. 3.54 times 10 to the 20th, not directly. But you can get at it. You can get sensors. You know how much of the solid angle around an object a sensor occupies, and you can look at what the sensor is doing from a certain distance. You can do a little math, in other words, right? Back this thing off till it can actually register the counts, right? And then there's all sorts of corrections you can do to arrive that it's a lot, a lot of decays per second, right? These formulas cheat. 61 seconds. Yeah, we got the same. Look at that. I just put the answers in there, so if you're looking at it at home, there it is.
Oregonium.
Oregonium. Let's try that one.
What is that? Half-life in day? Really necessary? Well, considering the ends are up there.
Oregonium. When we talk about the half-life of oregonium, we're talking about half-life of actually the school budget.
That's generous.
Yeah. Oregon's ability to pay for its own schools.